Welcome back to the Network Plus training series. In this lesson, we are covering Objective 1.6, Compare and Contrast Network Topologies, Architectures, and Types. Understanding how networks are structured is essential for designing, deploying, and troubleshooting them. In this lesson, we will examine physical and logical topologies, network architectures, and different types of networks. Let us start with network topologies. A topology describes the arrangement of devices and connections in a network. There are two perspectives to consider: physical topology, which is how devices are physically wired, and logical topology, which describes how data flows through the network regardless of the physical layout. The star topology is the most common physical topology in modern networks. In a star topology, all devices connect to a central device, typically a switch. The advantages of a star topology include easy installation and management, the fact that a single device failure does not affect other devices, and straightforward troubleshooting. The main disadvantage is that if the central switch fails, all connected devices lose connectivity. This is a single point of failure. A mesh topology provides direct connections between devices. In a full mesh, every device is connected to every other device. In a partial mesh, only some devices have direct connections to each other. Full mesh provides maximum redundancy and fault tolerance because if one link fails, traffic can use an alternate path. However, full mesh is expensive and complex because the number of connections grows rapidly as you add devices. The formula for calculating the number of links in a full mesh is n times n-1 divided by 2, where n is the number of devices. Mesh topologies are commonly used for WAN connections and backbone networks. A bus topology uses a single cable, called the backbone or bus, to which all devices connect. Data transmitted by any device travels along the bus in both directions. If the bus cable fails, the entire network goes down. Bus topologies are considered legacy and are rarely used in modern networks. They were common in early Ethernet implementations using coaxial cable. A ring topology connects each device to exactly two other devices, forming a circular data path. Data travels in one direction around the ring. In a dual ring topology, data can travel in both directions, providing redundancy. Ring topologies were used in token ring and FDDI networks. Today, ring concepts are still found in some WAN technologies and fiber optic networks like SONET. A hub and spoke topology is similar to a star but is typically used in WAN environments. A central hub site connects to multiple spoke sites. All traffic between spoke sites must pass through the hub. This is cost-effective because spoke sites only need one connection each, but it creates a potential bottleneck and single point of failure at the hub. Now let us discuss network architectures. The three-tier architecture is a traditional hierarchical network design consisting of three layers. The core layer is the backbone of the network. It provides high-speed switching and routing between different parts of the network. The core should be designed for speed and reliability with redundant connections. The distribution layer, also called the aggregation layer, sits between the core and access layers. It enforces network policies, performs routing between VLANs, implements access control lists, and aggregates connections from the access layer. The access layer is where end-user devices connect to the network. This layer includes switches that provide direct connectivity to workstations, printers, and other devices. The access layer handles port security, VLAN assignments, and power over Ethernet. In smaller networks, the three-tier model is often collapsed into a two-tier or collapsed core architecture where the core and distribution layers are combined into a single layer. This simplifies the design and reduces costs while still providing the essential functions. Spine and leaf architecture is a modern data center network design. In this model, spine switches form the backbone and leaf switches connect to the servers and other devices. Every leaf switch connects to every spine switch, creating a full mesh between the two layers. This provides consistent latency, high bandwidth, and excellent scalability. When more capacity is needed, you simply add more spine or leaf switches. This architecture is well suited for east-west traffic patterns common in modern data centers. Software-defined networking, or SDN, is an approach that separates the control plane from the data plane. The control plane, which makes routing and switching decisions, is centralized in a software controller. The data plane, which forwards traffic based on those decisions, remains on the network devices. This separation allows for centralized management, programmability, and automation of the network. SDN is fundamental to modern cloud and virtualized environments. Software-defined wide area network, or SD-WAN, extends SDN concepts to the WAN. SD-WAN allows organizations to use multiple connection types including MPLS, broadband internet, and LTE, and intelligently route traffic based on application requirements and real-time network conditions. It provides centralized management, application-aware routing, and zero-touch provisioning for branch offices. Now let us cover network types. A LAN, or local area network, covers a small geographic area like an office building or campus. LANs typically use Ethernet for wired connections and Wi-Fi for wireless. A WAN, or wide area network, covers a large geographic area, connecting LANs across cities, states, or countries. WANs use various technologies including MPLS, leased lines, and internet-based VPNs. A MAN, or metropolitan area network, spans a city or metropolitan area. MANs are larger than LANs but smaller than WANs. A WLAN, or wireless local area network, is simply a LAN that uses wireless technology, primarily Wi-Fi, for connectivity. A PAN, or personal area network, covers a very small area, typically a few meters around an individual. Bluetooth and NFC are examples of PAN technologies. A SAN, which in this context stands for Storage Area Network, is a dedicated high-speed network for storage traffic. We covered SANs in our previous lesson. A CAN, or Campus Area Network, connects multiple LANs within a campus, such as a university or corporate campus. Let us wrap up. We covered physical topologies including star, mesh, bus, ring, and hub and spoke. We discussed network architectures including three-tier, spine and leaf, SDN, and SD-WAN, and we reviewed network types from PAN to WAN. Understanding these concepts is critical for network design and troubleshooting. Thank you for watching this lesson on Objective 1.6. In the next video, we will cover Objective 1.7 on IP version 4 network addressing.